This is Science 8 readings for Lesson 5.3 WCS. The name of this article is Global Winds in the Ocean Conveyor Belt. The purpose for reading this article is to answer the question, what is the global ocean conveyor belt? Recall that air moves from high pressure areas to low pressure areas. Warm masses of air have low pressure because warm air is less dense than cool air, which causes it to rise and create a low pressure situation. Thus, a permanent low-pressure area exists in the hot temperatures of the equator. A permanent high-pressure area exists at each pole because the air masses there are cold and dense, causing them to sink and press down on Earth's surface. Winds blow from high-pressure areas at the poles to low-pressure areas at the equator. Because of the Coriolis effect, these winds are deflected to the right or left depending on the hemisphere. The Coriolis effect is a force that comes from Earth's rotation and affects the path of objects in motion, including circulating winds and surface ocean currents. So the first thing that I need you to underline is that air moves from high pressure area to low pressure areas. And I need you to write that at the top. Air moves from high pressure, so I'm going to do an H for high pressure, to low pressure. And remember that high pressure is cold air that's going down. Okay, it's cold air that's going down. It's causing a lot of force on the ground because it's going down. And then you have low pressure, which is warm air that goes up. And it's low pressure because it's not, as it's going up, because it's lighter, it's not exerting very much force on the land. So remember that air moves from areas of high pressure to low pressure. So that cold air goes down, has a lot of force on the ground, moves to the low force, or the low pressure, because it's warmer, and it goes up, so it's exerting less force on the land, so it's a low pressure. This is Science 8 readings for Lesson 5.3 WCS. The name of the article is Global Winds in the Ocean Conveyor Belt. The purpose for reading this article is to answer the question, what is the global ocean conveyor belt? Recall that air moves from high pressure areas to low pressure areas. Warm masses of air have low pressure because warm air is less dense than cool air, which causes it to rise and create a low pressure situation. Thus, a permanent low pressure area exists in the hot temperatures of the equator. A permanent high pressure area exists at each pole because the air masses there are cold and dense, causing them to sink and press down on Earth's surface. Winds blow from high pressure areas at the poles to low pressure areas at the equator. Because of the Coriolis effect, these winds are deflected to the right or left depending on the hemisphere. The Coriolis effect is a force that comes from Earth's rotation and affects the path of objects in motion, including circulating winds and the surface ocean currents. So the first thing that I need you to underline is that air moves from high pressure areas to low pressure areas, and that warm masses of air have low pressure, so remember guys, when air moves, it's a convection current, it's a circle. And so air always moves from high pressure to low pressure. Also remember that low pressure is warm air. It's going up. Okay, it's not having the low pressure is not putting a lot of pressure on the ground. It's low pressure. The air is going up. Okay? Now with high pressure, you're talking about cold air, right? And cold air is pushing down or going down. Okay? As it's going down, it's heavy and dense and it's going down and it's pushing down on the ground. It's causing a lot of force. It's causing a lot of high pressure force. And so that cold air is causing a lot of pressure and it always moves to a low pressure place. It gets warmer and it rises. And you have that circle again. So next I need you to underline that there's a permanent low pressure at the equator and write that at the bottom. The L with the circle means a low pressure because at the equator it is warm and so the air is going to want to rise up. Okay, and since it's rising up, it's not creating very much pressure on the ground. The next thing I need you to underline is that there's always a high pressure at the poles, and write that on the side. That H with the circle is high pressure. And if you think about it, you're creating a high pressure because that cold dense air is at the poles because it's cold at the poles. That cold dense air is coming down and pushing down on the ground and causing a lot of force. So at the equator it's warm, air is rising, you have a low pressure. At the poles it's cold, air is sinking and pushing and it's going to have a high pressure. Also remember that air always goes from high pressure to low pressure. So I want you to think of it this way. So here's the world, and this line right here is the equator. So at the poles, you have high pressure. And remember, in the high pressure, the cold air is sinking down and putting pressure onto the surface of the ground. And you remember also that at the equator, you have low pressure because it's warm there and the air is getting warmer, so it's rising up. Also remember that air goes from high pressure to low pressure. And so you would think that the air would go from the poles straight down to the low pressure at the equator. But that's not true this time. So because the Earth is rotating, it's causing the wind to actually, when it's coming down, to actually curve to the left in the northern hemisphere and curve to the right in the southern hemisphere. And this is called the Coriolis effect. Ocean currents are also affected by the temperature and salinity of water. Just like air, cold water is denser than warm water, causing it to sink. The salinity of ocean water changes its density as well. Ocean water with high levels of salinity, very salty, are denser than water with lower levels of salinity. These rising and sinking ocean waters result in a predictable pattern of surface and deep ocean currents that circle the globe. So the first thing that I need you to underline is that cold water is denser than warmer water, causing it to sink. And I need you to write on the side that cold water is heavy and it goes down and sinks. Water is just like air. Okay, the cold water or cold air is heavy and goes down. And just the opposite, if you have warm water, it rises just like warm air also rises. I need you to underline ocean waters with high levels of salinity, or it's very salty, are denser than water with lower levels of salinity. And I need you to write on the side that salty water is heavier, it's denser, so it goes down. And if you don't have as much salt in your water, It's not as heavy, and so it goes up. Flowing northward along the east coast of the United States is a tremendously warm water current called the Gulf Stream. Do not confuse this with the jet stream, which is a fast-moving air flowing high in the atmosphere. The Gulf Stream carries huge amounts of warm tropical water, about 44.6 to 71.6 degrees Fahrenheit, into areas farther north. It is fairly salty water. This is because it originates from warm water in the Gulf of Mexico, and very warm water tends to evaporate, leaving salt behind. Wind steers the Gulf Stream away from the coast of North America and moves it eastwards towards Europe. Okay, so the first thing that I need you to underline is that this is a warm water current called the Gulf Stream. And then I need you to underline the word jet stream, which is a fast-moving air flow high in the atmosphere. So you need to know the difference between the Gulf Stream and the jet stream. Okay, so I need you to write difference, and the Gulf Stream is a warm water current. And the jet stream is a fast-moving air. So the next thing that I need you to underline is the part where it says, because it originates from warm water in the Gulf of Mexico, and very warm water tends to evaporate, leaving salt behind. And I need you to write in the margin that the Gulf Stream is really salty because it's very warm in that area. So the water evaporates, but it doesn't evaporate the salt. It leaves the salt there. So the leftover salt makes the water that's left over even more salty. As it moves north into much colder climates, it cools to about 51.8 degrees Fahrenheit, releasing heat to the atmosphere off the coast of Europe. Gradually, the Gulf Stream widens and slows as it merges with the broader North Atlantic Drift, a current that flows towards the British Isles. To the west of the United Kingdom, the North Atlantic Drift splits, with one arm approaching the chilly Barents Sea north of Norway and the other flowing along the coast of Greenland. As these waters flow northward, the water cools to around 30 degrees Fahrenheit as they release more heat to the atmosphere. As the surface water freezes, it leaves salt behind, making the cold water under the ice even saltier and denser. This dense seawater sinks to depths of as much as 9,800 feet. So I need you to underline the words that when water freezes, it leaves salt behind, and making the colder water under the ice under salter and denser, and this dense water sinks. So I want you to write on the side, the surface water freezes, leaving salty water underneath that ice, and that salty water goes down. Remember that the saltier the water, the more dense it is, the more heavier it is, and so that water, that salty water, sinks down. Here. This process is ongoing, with the Gulf Stream continually bringing new water northward. The water grows colder and denser in the Arctic and then sinks, creating North Atlantic deep water. The deep, dense, cold NADW that flows southward as a bottom current past Africa and all the way to the Antarctic. As the water moves eastward by Antarctic, it splits into two currents. One flows north into the Indian Ocean, and the other continues eastward into the Pacific, where it turns north along the coast of New Zealand. So we have a bold vocabulary word. So I need you to circle North Atlantic deep water. And I need you to write that it is a cold, salty, deep ocean current in the Atlantic Ocean. As the currents approach the equator, they warm up and rise to the surface, otherwise known as upwelling. After looping around, they rejoin into one surface current, which heads back westward and eventually reaches the Atlantic Ocean, where it joins the Gulf Coast or Gulf Stream. This ocean current system, which results in huge energy exchanges due to differences in heat and density, is called the global ocean conveyor belt. It is estimated to take approximately 1,000 years for the water in the conveyor belt to make a complete circuit. Can you trace its movement and temperature exchanges on the map? So we have another vocabulary word that I need you to circle. It's global ocean conveyor belt. So guys, this right here, this picture is the global ocean conveyor belt. And what that means, it is a slow moving ocean current that circles the world. And I need you to write that, please. So if you notice in the picture, you'll see the ocean current. Red is warm, blue is cold, and it circles the earth. And they said in the reading that it takes 1,000 years for this thing, the water, to circle the earth just one time. So let's pretend that we have a drop of water right here by the United States and it's warm. And so here's a slow moving current. It's warm and then it starts to cool down and it goes down deep into the ocean at the bottom and it keeps going. And then it goes past Australia, goes past Japan, keeps going, it's warm, right? And it's on the surface and it goes all the way back to the United States. And that takes 1,000 years. End of recording.